In the world of industrial automation, the PLC acts as the brain, commanding everything. But how does it sense those continuously changing signals from the outside world? Water tank levels, pipeline pressure, furnace temperatures. These are not simple on-off states, but precise analog quantities. Today, we're going to unpack the mysteries of analog signals. Real-world signals are continuous analog quantities, but PLCs can only process digital values. This requires an analog-to-digital converter to sample and quantize them. Drag the fill tank slider. The simulated voltage changes smoothly, but the PLC reading jumps in discrete integers. Switch the resolution to 1-bit, 3-bit, or lower, and you'll see obvious steps. That's quantization error. The higher the resolution, the finer the steps, and the closer the digital value gets to the true analog signal. This is why high resolution is so important in industry. Voltage-based inputs are simple, but they have many problems in industrial environments. The longer the cable, the greater the voltage drop in the sensor's output signal. Now start the noise source. The waveform instantly becomes full of spikes, and the voltage fluctuates wildly. When it comes to detecting wire breaks, the 4 to 20 milliamperes current loop is the industrial favorite. The sensor outputs 4 to 20 milliamperes, and the PLC uses a 250 ohm resistor to convert it to voltage for processing. Perfectly linear. Compare wire break scenarios. When adjusted to 0 bar, both systems display normally. But cut the wire, the 0-10V system drops to 0V and thinks the pressure is truly 0. The 4 to 20 milliamperes drops to 0 milliamperes, far below the 4 milliamperes lower limit, triggering an immediate alarm. It's a wire break. The two main players in temperature measurement, thermocouples and RTDs. At different temperatures, the two materials exhibit different physical property changes. Thermocouples change voltage, while RTDs change resistance. The transmitter directly converts these voltage or resistance changes into standard industrial signals for the PLC, enabling the PLC to accurately recognize temperature data.